This is lesson 1-4, patterns and functions. A function is a relationship that assigns exactly one output or y value for each input or x value. For example, if I have an x value of 3 and a y value of 4, and an x value of 6 and a y value of 7, or an x value of 2 and a y value of 9, that would be a function. If you ever have an x value that repeats, if I was going to repeat 3 again, the y value better be 4. If it's anything other than 4, it's not a function. Every time x is 3, y has to be 4 in order for this to be a function. A function rule is an equation that describes a functional relationship. It can be just as simple as saying P equals 4S, which is the formula for finding the perimeter of a square. As long as you know what P and S are, you can evaluate that function. If you don't, then someone needs to tell you what those are so you can evaluate the function. A dependent variable is a variable that provides the output variable value for the function. A dependent variable relies on something else. It depends on it. Children are considered to be dependents because they are dependent on their parents for food, for shelter, for transportation, basic living arrangements. Therefore, they are considered to be dependents. A dependent variable means that it relies on something else. In my x and y table above, all my y values up here are dependent. They all depend on my whatever my x value is. For example, if I sell magazine subscriptions, the money I earn depends on the number of subscriptions I sell. Therefore, money earned is dependent. Excuse me, messed that up. And number of subscriptions is independent. An independent variable is a variable that can stand alone. It is the input value. Okay? The number of my subscriptions doesn't depend on anything in the above example. A domain is the possible value for your input or x variable. In other words, it is the independent part. The range is your possible values of your y or output variable or your dependent variable. Let's look at an example. We're going to write a function rule. Suppose you're baking batches of muffins for a bake sale. The relationship between the batches, the input, and the number of muffins, the output, is a function. So this is my input, and this is my output. We're going to use this table to write a function rule. In order to write a function rule, we have to find the relationship between the number of batches and the number of muffins. And if I look at each one of these numbers, I should be able to recognize that if I multiply 1 times 12, I get 12, 2 times 12 is 24, 3 times 12 is 36, and 4 times 12 is 48. So we are multiplying the number of batches by 12 in order to get the number of muffins. So the total number of muffins is 12 times the number of batches. To translate this into a function rule, we need to define some variables. And I just decided to do something fairly simple. I let n equal my number of batches, which happens to be my input, which is the independent variable. I let m be my number of muffins, which is my output, which happens to be my dependent variable. So, if I let n equal the number of batches, and this is my input, my output is going to depend upon my input. Most of the time, you write your function rules starting with your output or your dependent variable. So in my case, I'm going to let m, my number of muffins, is going to equal 12 times the number of batches that I happen to make. So m equals 12n. Let's look at another example. The French Club is holding a car wash fundraiser. they are going to charge $10 per car and expect between 50 and 75 cars. We're going to identify the independent and dependent quantity and find a reasonable domain and range. So the first thing I have to look at here is I have to look at the fact that I know a couple of things. I know that we are going to charge $10 per car, and we hope to have between 50 and 75 cars show up at this car wash. So cars and money are either dependent or independent. Does the number of cars depend upon how much money I make, or does how much money I make depend upon the number of cars I wash? Well, it's quite obvious that the more cars I wash, the more money I will make. So in this case, cars are going to be the independent variable, and money is going to be the dependent variable. So my independent variable, which you can just abbreviate as IV, is going to be the number of cars. And my dependent variable, which I can just call DV, is going to be the amount of money I make. The domain and range are always related back to the independent and dependent variables. My domain is always related to the independent variable, and my range is always related to the dependent variable. So all I need to do here then is I need to be able to figure out what's a reasonable domain and range. Well, they basically gave us the reasonable domain because they told us we were going to wash between 50 and 75 cars. So my reasonable domain is between 50 to 75 cars. My range is how much money I will earn if I wash 50 cars, and how much money will I earn if I wash 75 cars. Since we are earning $10 per car, we simply need to multiply 50 times 10 and get $500, and 75 times 10 to get $750 to figure out what our range is. And remember, 500 was found by taking 50 cars and multiplying it by $10 per car. And here, $750 was found by multiplying 75 times $10 per car. Your range is always related back to your dependent variable, and your domain is always related back to your independent variable. Let's look at a second example. Ken burns 425 calories per hour when he bikes. He bikes for 3 to 7 hours each weekend. Again, we're going to identify the independent and dependent quantities and find a reasonable domain and range. So we look at this and we have two things that we're focusing on. We are focusing on calories burned and hours biked. So if we look at that, does the number of calories he burns depend upon the number of hours he bikes, or does the number of hours he bikes depend upon the number of calories he burns? Do I burn more calories when I bike longer, or do I bike longer because I burn more calories? Sometimes people can get confused about this, but it's pretty clear that the more I bike, the more calories I burn. Therefore, my independent variable is going to be hours that I bike, and my dependent variable is going to be calories burned. Because the more I bike, the more calories I burn. Since my independent variable is related to my domain and my dependent variable is related to my range, a reasonable domain is reasonable how many hours am I going to bike? Well, the problem told us we were going to bike between 3 to 7 hours, so my domain is between 3 and 7 hours. My range is going to be how many calories did I burn on the low end of my domain, which would be 425 times 3, to how many calories am I going to burn on the high end of my domain, which would be 425 times 7. So if we multiply 425 by 3, we should get 1,275 calories. And if we take 425 and multiply it by 7, we should get 2,975 calories. And remember, we found this by multiplying 425 times 3. We found this by multiplying 425 times 7, because that's the number of hours we were going to bike. As you can see, functions are not all that complicated.